Okay, all right. Well, happy Wednesday. And today we're going to get into data visualization. I'm going to introduce Ggplot. Read the rest of chapter 2 on your own. I have a few slides in talking about chapter 2, and maybe we'll revisit some of those concepts later. Maybe we won't have time. It depends, I guess, how much time we spend on Ggplot and this whole concept of data visualization. Okay, so I imagine you have created graphs of data or something at some point, right? Like in middle school, you probably did like a science experiment, and then you had to make like a bar chart or a line plot or something, right? I imagine we've done something like this, right? So this concept of like visualizing data is not all that weird. I don't know how strict your teachers were, but when you like submitted a picture of a plot, did you lose points if you forgot to label one of your axes, or you lost points if you like didn't put your tick marks or something like that? Okay. And that's good. That means like your teacher did a good job, because those are very important. Because when we talk about data visualization, there are kind of two key aspects. And I think the first part is what you guys learned, or have a basic idea of, and that is you have a table of data and you turn it into a visualization, and we give you all of these rules, like, oh, you gotta like label all of these things and stuff. Okay, all right. Let me just back up a little bit here, and some of this stuff is coming from this textbook, the R Graphics Cookbook. I think you can read the book kind of in your browser right here, as well as I think I've linked in our syllabus, or at least in your things, link to textbook. What do I have here? Okay, so you can also click this link, learning.o'reilly.com, and part of your tuition money goes to pay for all of this library access, okay? And so you can say, I'm with UCLA, you sign in with your institution, you get your familiar like UCLA sign-in, and then you can also read the textbook in your browser here, okay? And so I don't know if you are familiar with like the O'Reilly books. You go to any kind of bookstore, there's like a computing section, and it's all like, pretty much every single book in the O'Reilly catalog, which is huge, and each of these books are usually like $50-$60 a pop. You can read them all right? You can read them all. You just you say, oh, I want to learn, I don't know, Python, okay? And there's a ton of Python books and stuff.
Are they all lizards?
Why are they all lizards?
Yeah.
O'Reilly has this weird thing where they like to put little animals. I think this is a snake.
You know, like the middle school.
This one's a snake. This one's a lizard. This one's a, I don't know what this is. A marmot? I don't know.
It's like a prehistoric animal.
Okay, we're getting off track. What is that?
It's called Python.
This is not a python. All right, I don't know what animal this is. Okay. All right. Anyway, and this is not a lizard. This is, I don't know. It looks like a moose, but it's like too small. But anyway, okay. Anyway, we're going to talk Ggplot. All right, Ggplot created by Hadley Wickham, part of this thing called the tidyverse, and we're going to be getting familiar with the tidyverse. So there's R, and one of the strengths and also, I don't know about weakness, but it's like, what are your weaknesses? And these are my strengths. One thing that's great, but also frustrating about R is the ability to create a new package. And R is kind of very decentralized in that if you wanted to create and publish a new package, a new set of functions, a new set of ideas and codes, you can do that. And there's a whole bunch of different things. Within R, there's a set of packages that are collectively known as the tidyverse, which has a certain kind of, I guess, philosophy as far as how the packages were designed. And Ggplot is the kind of the data visualization aspect of that. Okay, the GG stands for Grammar of Graphics, and it just kind of creates a set of formalized ideals regarding what a data visualization is supposed to be. So, right, if you think about language, and we have these grammar rules on how things are, your sentences and are supposed to be structured. We have something similar for graphics, okay? That there is kind of this set rules to kind of explain what a data visualization is supposed to be, okay? You can also create graphics with base graphics. So within R, there are abilities to create plots, and Ggplot is like I guess an optional add-on package, but I think it's a pretty good one. And so we're going to be consistently loading this library or this package of things, and we're going to be using Ggplot's tools to create our graphics. So if you were to go on some other person's computer and they say, oh yeah, I have R on my machine, if you don't load in Ggplot on their machine, then you won't be able to create these graphics and stuff. Okay? Yeah, question.
This is not directly related, but when you use the words packages and libraries, are they
they're pretty much interchangeable, okay? At least as far as languages here and for R. So I use package and libraries interchangeably. Another word is like module. Like in Python, we often call them modules and stuff. So the big idea with a data visualization and a data graphic is we take properties of the data and we map them to visual properties of the graphic. Okay, so one idea is if you're going to make a scatter plot, you have an x-axis, you have a y-axis, and we are going to map the x position to some data value, okay, or the y position to a data value, maybe color of the point to a data value, maybe the symbol that we used gets mapped to some kind of data thing. And if we are not mapping properties of the data to visual properties, it's not a data visualization. All right, so here we're gonna start off with this very simple toy example where I have information for 6 individuals here. I always want an excuse to use my my pointer here. So so we've got these, what is this? Lint on this. Okay, so we have these 6 individuals, okay? And this is just some made-up information. So this is someone's height, 62 inches tall, 5'2", weight 120 pounds, gender female, hair brown, and we have 6 people, and so on and so forth. We have this information. And what we want to do, right now there's not anything super fascinating about this data set, but let's say we want to visualize this, okay? We want to create a plot. So I think we could do this. Like if I gave you this assignment right now, I said take out a piece of paper. We're not going to do this, but and I said take out a piece of paper and graph everybody's height and weight. I think you would do this, right? You'd start off and you'd put like one on one axis and the other on the other, right? So we can do height here and weight up here. And then you would need to come up with something. So it looks like our smallest number is what? 62, and our biggest number is 72. So I'm going to just start off at what? Say 60. All right, and then what's vertically our smallest number is what? 120 and going up to 190. So I'll just start off at And I would say, here's my first point, 62, 120. So we'll go at 62, and I'll put a dot right here for 62, 120. And then we go through. The next point is 67, 140, 67. Oh, did I count wrong? 120 is right here. 140, 67, something like this. And we would create our plot like this. And I think we would be able to create a scatter plot for these 6 data points. And that would not present a challenge, right? We're all okay with this. Okay, so what I'm doing here is we are mapping the height to the x position, okay? And then we're going to map the weight to the y position. You'll also see I mapped the 2 categorical variables. I mapped gender to the color, and I've also mapped hair to the shape. So hair, we have brown, black, blonde, so on and so forth. And so when I do this, this ends up being the plot that gets drawn, okay? And so this individual, what can we say? This person has a height of 62, a weight of 120. What color is this person's hair? Brown, because it's got a square, right? So we have the square shape, and so the square shape corresponds to brown, and then it's whatever this color is, red, salmon, something, okay? And we're gonna say that corresponds to female, okay? And what about this individual? How tall is this person? 65. Weight is 160. Hair color, blonde, gender, female. Okay, and basically we can see, oh yeah, you know, there is a person, 65, 160. Is that what I said? Yeah, female, blonde. Okay, that's this individual right here. So we have mapped aspects of the data to visual properties. Okay, and this allows us to utilize kind of the visual processing parts of our brain to think about quantities and values, okay? Because if I said, hey, is there a relationship between height and weight? Looking at these numbers, it's a little bit hard to think about, okay? I think perhaps, you know, if we think about it, like stare at all of these numbers and we try to arrange them in order from least to greatest, like we might find some kind of general trend that smaller numbers of height are generally associated with smaller numbers of weight, larger numbers of height are generally associated with larger numbers of weight. And that might be obvious because of the labels on these things, but let's say you just had, you know, the arbitrary labels X and Y, and I said, is there some kind of general trend? Is there a pattern between X and Y? It's a lot harder to reason about it when you have only the numbers to look at, because this requires your brain to look at the numbers, think about the number, and that's different from seeing dots on a plot, okay? And when you see dots on a plot, it's a lot easier for your brain to say, oh yeah, you know what? There's a general trend where we start off in the lower left-hand corner and we end up in the upper right-hand corner, and we see kind of this, that kind of pattern, right? You look up at the stars and you can't really see stars in LA, but the idea is you can see random dots somewhere and you can start establishing whether or not there's a pattern. You can decide if there's a cloud of points or if there is some kind of trend or anything like that. And that's because we're utilizing the visual processing parts of our brain, okay? So again, yeah, when we look only at the numeric values, it's not as easy to reason about them. But when we see them as points, we're able to process that, okay? So far what we've done is we've mapped the properties of the data to a graphic. But just as important, because a data visualization is not useful if you cannot do the second part, which is allow the viewer of the graphic to map what they see visually back to the data. So we need to be able to go from the data to create the graphic, and that's probably what you did in middle school. But just as vitally important is we need to be able to go from the graphic back to the data. Okay, so if I present this graphic to you, and I said, I want you to recreate the data table, all 6 rows and all 4 columns, you are able to do it, right? Because you can look at this point and you can say, all right, this person has a height of what? About 67, has a weight of 140, gender female, has black hair, okay? This person has a height of 66, a weight of 135, male, brown hair. Okay? And you can go through every single data point and we can recreate the data. Right? And that is just as important. That is just as important to be able to go from the graphic back to the data space. And if we are not able to do that, right? So if I take this away, if I hide this, we would not be able to recreate the thing. We would say, okay, there's got to be 2 groups, but we might not know which group is what, okay? If we take away the axis, right? If we forget to label our axis and we don't say this is the variable that this horizontal axis represents, again, we're not able to kind of recreate our data space, our data labels. So if you leave off, any of those, what we call guides, okay? So axis labels, tick marks, the legends, if you leave any of those things off, we're not able to recreate this thing, which is just as important, all right? And so, there on the internet, there's like different places, and one of these things is there's Data is Beautiful on Reddit, and spoiler alert, not everything on here is beautiful, okay? And so there are like visualizations where it's difficult. It's difficult to go back to the visual space, okay? Or so here is like I guess a map of the United States by the states, and then they're shaded in with different colors. And I guess what we're supposed to see, there's only 2 variables being plotted. What are the 2 variables? Yeah, what?
It's state and then the ACT score.
State and the ACT score. And we can kind of get the ACT score based on the color. It's hard to get the exact value, but that's okay. But I don't know if is there like a trend that we're supposed to pick up? The New England has higher ACT scores. The South has lower ACT score. The Deep South maybe. And then this is all like everybody else is just kind of average. I don't know. Nevada is something happened between Nevada and California, right? I don't know. Okay, but this doesn't. I don't know. I'm not sure how useful this thing is. Okay, what do you think is going on? Like, why is California so bright red compared to like Nevada and Arizona or something? Yeah, what do you think?
High amount of immigrant families wanting to like study more so your kids can get ahead. So you just force your kids to study.
I don't know. How many of you took the ACT? A lot of you? Okay. I'm not surprised because you guys are here at UCLA. Wait, and those of you who raised your hands, are you all from California or out of state? I don't know. Okay. So I think in California, as far as standardized tests go, I think the SAT is more popular than the ACT. Like, how many of you took the SAT? Okay, like all of you did, even though we said like we're not going to use SAT. And then again, how many of you took the ACT? Okay, so like a subset. So some of you took both and stuff. And so my guess is in California, college-bound students will probably take the SAT. Okay, and then if you're not going to go to college, you probably won't take the ACT. And of the people who are going to take the ACT in California, I imagine it's because like you know what, I think I'm going to score well on the ACT. I think it's going to be an asset on my application. And so people who are going to take the ACT in California are going to be just naturally higher scorers in terms of like, there's like a self-selection bias, right? Like you're going to select this or something. Yeah.
There's actually a study. The reason why we're so high is basically because our population is just bigger. Like we have a much bigger population than a lot of places on this.
We do have a huge population, but but Texas has a huge population too, right? Okay, and so I think the big, and so does Florida. Okay, I think the big difference is that in California, the de facto kind of standardized test is the SAT. The ACT is more seen as an optional thing. Who's going to be taking the ACT if it's optional? Only students who probably will think they're going to do a little bit better, and so there's a self-selection thing. And of course, that doesn't apply to everybody, but yeah.
So you would expect the SAT chart to look kind of the opposite?
Not necessarily the opposite, but I think as far as the SAT goes, I think California will probably be a little bit closer to average. I don't know.
Find the SAT.
I have no idea. Okay, this is just my guess. Okay, but this is based on my kind of like, I don't know, kind of inside knowledge of a little bit of like college and stuff like that. Yeah, I didn't mean to start off this whole debate here.
I just found a similar chart of whether SAT or ACT are more popular.
Okay.
Funny enough, Nevada actually SAT is more popular also.
Okay.
But it doesn't have the same effect.
And Nevada SAT is a lot more popular. Okay.
And also Texas and most of the coastline actually.
Yeah. ACT is generally more popular in the Midwest. There's but
there's a lot of
I don't know. So again, I don't know what this is supposed to say. There's really only two things being plotted here, and that's the state and the ACT score. And that's it, okay? There's no, like, this requires our kind of just internal knowledge. Like, if you were not from the United States and you didn't know that much about the different states, like, you wouldn't, there's nothing about, like, the population, right? Like, that's probably an important thing. There's nothing about, so a lot of these other things are left off. This is all, the viewer of this, the person who created this graphic is hoping the viewer is familiar with the 50 states, hoping the viewer is familiar with, some of these things. But that's why if you, if we were to say, look at a plot about, what is this? World's top cheese producing countries per capita. Okay, great. And, if you're not that familiar with, certain regions of the world, these graphics are a lot less kind of useful. I think, I don't know, a lot of people like maps in the first place, so I mean, maybe that's great, but anyway, all to say, what's just as important is being able to go from the graphic back to the data set. Okay, we got a lot more stuff. Yeah.
Oh yeah, I think their theory was somewhat correct. I found the map for the SAT, and then higher scores are all in the Midwest, minus Texas.
Okay, so as far as SAT scores, higher scores are in the Midwest versus Texas, where they, I don't know what's going on with Texas, but I don't know. So, but that kind of graphic or that kind of reasoning requires you to be kind of familiar with that subset, I guess. Yeah.
Well, but for example, like the cheese production and the map one, like to what extent is it like the presenter's responsibility to know that the viewer is like familiar with like the country? So I feel like if you're like giving a presentation about cheese production for whatever reason, like I feel like this context, like isn't it kind of expected that people like can know that like what regions of the world or can you at least like in a presentation like say,
this is very important, is you have to know your audience. Okay, so if you're talking to first graders, it's not going to be helpful, right? To go and kind of go down to a country level, unless part of your presentation is to provide some of this context, and you say, okay, this part of the region, they like to eat cheese, and this part of the region, right, like. Going back to this, right? Or I guess so you know your audience, or there's certain things that you might want to try to point out, okay? And so we see a lot of cheese being produced in Europe, and like very little cheese produced in Africa, okay? And there's all kinds of things, but you know, one of the key things is kind of the ability to process lactose, okay? And just kind of genetically and stuff, like Europeans in general are able to process lactose, and as far as like people from Africa and Asia are a little bit more likely to have, you know, lactose intolerance or lactose sensitivity types of things. And so, yeah, you're going to be eating less cheese, okay? And I don't know, is that the point of this graphic? Is that like a thing? Or is it, they're just saying like, oh, you know, Denmark eats a lot of cheese? I don't know. I don't see anything mentioned about this. But these are just like Wisconsin. Okay, yeah. And that's...
This board. Oh, this sounds like a fun idea.
Yeah, you know, I mean, so sure, we can make graphics, but I guess what is it that you're trying to communicate? You know, are you able to provide some context? Are you able to provide some of this background information that may or may not be useful, may or may not be relevant, right? And depending on what it is that you're trying to do. Okay, but anyway, let's talk about some of these things. And before I forget, let me go ahead and give you your first view quiz answer for today. And your first answer today is the letter A. A as an apple. A as an apple. So the data is basically what we want to visualize. We've got variables, and we store them as columns in our data frame, okay, our table of data or a data frame. The geomes, these are the geometric objects. So right now, the geometric objects are basically the points that we are drawing. The square and the triangle and the circle. These are the points that represent our pieces of data, okay? If you have a bar chart, the bars are your geometric objects that are representing your data, okay? And then we have aesthetics. Aesthetics are visual properties of the geometric objects, okay? So in our case, what are the properties of the thing? Okay, right now, one property is where it is positioned horizontally. Where is it positioned vertically? Okay, those are the position on the X and Y axis is an aesthetic attribute. Okay, the shape, right now it's a square, that's an aesthetic attribute. The color is an aesthetic attribute. There are other things we could also manipulate. We could manipulate the size of the object. We could manipulate how light or dark it is, right? So if you're dealing with just kind of like one color, you can have it, you know, transparent on one end or like nearly transparent to like fully shaded in, right? So like you can have kind of like a brightness or a lightness to as another aesthetic attribute. There, you know, different properties there. If you're drawing lines, it can be like the color of the line or whether the line is dotted. And then the mapping is which data values or which variables correspond to which of these visual aesthetics. Okay, so that's the part that goes into producing it. And then I guess the important part is being able to view and understand it. Is you have scales. Scales map values in the data space to the values in the aesthetic space. So scales will say, okay, what's basically the smallest value in your data, what's the largest value in your data, and basically what is the range of values that we could represent visually, okay? So as far as like shading levels, the maximum range is going from clear to opaque, all right? And like halfway translucent would be halfway in between, okay? And perhaps in your data space, if your numbers, if they go from 0 to 100, then you'd want 0 on one end and 100 on the other. If your data space, your values go from 10 to 15, then your scale is going to be different. 10 will probably be your lightest, and 15 will be your darkest, or something like that, right? So the scale on which values correspond to what visual property on one end versus the other, that's important, okay? Another thing is just like on the scale here is like, this is the farthest left I can plot. This is the farthest right I can plot. So you want to make sure your left edge is able to accommodate your minimum value. Your right edge is able to accommodate your maximum value. Okay, so I mean that seems pretty straightforward, but that's important as far as determining a scale. Okay, and so if you're trying to plot something like income, where your minimum is going to be 0 and your maximum might be like 10 million or something, to, you know, or like if we're talking about athletes, right, it might be like $30 million a year or something. Then you say, okay, well, if my right edge has to accommodate 30 million, you know, what should my plot look like? And then we realize, oh, you know what? A traditional linear scale where everything is evenly spaced out might not make sense, because pretty much everyone between $100,000 and $200,000, which is going to cover like 99% of people, is going to be all kind of compressed within this tiny little space if we have to go from 0 to 30 million. So, you know, so then we have to think about like, okay, maybe I need to use a logarithmic scale or things like that. So we have to think about how do we control the values in our data to the visual properties, right? And then once you've done all of that, you have your guides. The guides allow you to go from the visual properties back to the data space, okay? And your most common guides will be things like your tick marks, your axis labels, and your legends. So in the plot, and we're going to kind of just continue to work with this toy example, is we have our geometric objects, our points, and we mapped these 4 variables to different aesthetic attributes. And so as far as the point geometries, 4 of the aesthetic attributes are the X position, the Y position, the color of the dot, and the shape of the dot. And here I mapped the gender to the color and hair to the shape. Okay, so these scales were determined automatically by Ggplot, and so Ggplot looked at our data and they said, okay, you know what? The smallest value I think is 60, and the largest value we have is 72, and so they kind of just arbitrarily chose 59.5 and 72.5. You know, gave it a small little buffer on each end on the x-axis, and you know, vertically, I think the smallest value is 120, and the largest value is 190, and it arbitrarily said, okay, the bottom edge of my graph will be 118 and the top edge will be 192. So that was automatically determined by Ggplot. If you had to do this kind of manually, you know, when I created this, started drawing this, I looked at my data set and I said, okay, what's the smallest value? And I said 62. So I'm going to just start off at 60, and I went up to, I just started drawing tick marks and I ended up at 75 or something, right? But yeah, if you didn't know and you just started arbitrarily writing numbers on the number line, you started off at 0, okay, you'd have to be writing a whole bunch of tick marks before you can even start plotting any points, right? So it's always important to look at the data first to kind of see what's the range of values you see in your data, and then you determine how you're going to draw your axes as well, okay? Ggplot does a lot of this stuff for us automatically, but you might be aware, and you say, well, you know what? In our data set, you know, I only have like the first 5 values so far, but I know these values will grow as big as like 200. And you know, right now the largest value I have in my data set is 150. So you might want to kind of prepare yourself, plan for the future, and say, you know what, we need to leave additional space, right? Or maybe you're trying to create a map so you can plot things over time, and you say, okay, well, we started measuring this in the year 2000 and it's the year 2022, but I want to continue using the same graphic until the year 2030. So then even though your data only goes from 2000 to 2022, you might want to make your horizontal axis to go up to 2030 or whatever it is, right? Okay. Ggplot also automatically chose things like salmon and teal to represent the genders and whatnot, but you can control that yourself, okay? It also chose the shapes circle, triangle, and square, and that's what we have, okay? And then the guides, the legends, and the tick marks, those were all kind of automatically created by Ggplot. So Ggplot does a lot of this stuff automatically for us, and we are grateful for that, but a lot of these things we can also kind of control ourselves. All right. so again, here's our scatter plot. And we could change some of these mappings. Right now, I have the gender of the people in our data set mapped to the color, all right? And I've got the hair color mapped to the shape, right? And this, again, this is just a tiny little data set of 6 people, all right, where, you know, in our data set, we only had 3 hair colors represented. We only had 2 genders represented in our data set. And again, larger data sets, you're probably going to need more categories and things to be able to represent everybody, okay? But so this is what we have. We have gender mapped to the color, and we have hair mapped to the shape. What if I flipped that around? What if I flipped this around and I've said hair color gets mapped to the color, and gender gets mapped to the shape? How would that affect the plot? What would we end up seeing? Yeah.
Like all the data points will still be in the same spots, but now you'll have 3 colors for each, like, to choose from for the hair, and only 2 shapes.
Yeah, so exactly. So the X and the Y have remained the same. X is still height and Y is still weight, so everything's going to remain in the exact same spot. But now we're going to have 3 different colors represented in our, as far as the color of the points, and then, yeah, we're only going to see 2 shapes. And so this is what the plot looks like, okay? So now I have blue points to represent brown hair, green points to represent blonde hair, and I'm just going to call this red, okay? Red to represent black hair. And then I have circles and I have triangles to represent our genders here, okay? So if I'm going to just flip back to pictures, okay? So this is what we originally had. We had 2 colors and 3 different shaped points. Same positions, but now we have 2 shapes and 3 different colors. Okay, but if you look at this, you can see, like, look at where the circles are. Okay, where those 3 circles are the exact same spots where the 3 orange point or 3 red points are. Okay, look at where the 2 squares are. Okay, these 2 squares are the same points where the 2 blue points are, right? So it's the same data, and if I gave you this graphic and I said recreate your the data set with the 6 rows and the 4 columns, you would also be able to do this, okay? So these are both kind of 2 representations with just slightly different aesthetic mappings. Okay, now one thing to note is that our eyes usually will notice the color before they notice the shape, okay? So you're probably going to notice the color of the points before you notice the shape of the point. You know, I don't know if we have anybody who's colorblind, and I don't know if these do these look distinctively different, or are they like?
I'm not that bad. I'm
Okay.
not like totally blind.
Okay. Well, I know like red and green often presents issues for a lot of people, and I mean, there's different kinds of color blindness and stuff. So I guess speaking for most of the general population, people will notice color first before they notice shape. And so usually whatever variable you want to kind of draw more attention to right away, you might choose to represent that with color. And then the ones that are, you know, I guess secondary in importance, you might choose to represent with shape. And so depending on what it is that you're trying to kind of illustrate, that might inform how you want to do this. Okay, before I forget, second view quiz answer is the letter B. B as in bear. B as in bear. Okay, what if I do this? So here I'm going to say map the hair color. So remember, we have 3 hair colors. We have brown hair, blonde hair, and black hair. And can I do this? Can I map hair color to Y position? What would that end up looking like? Yeah.
Would it just be like a graph with 3 tick marks? Like the y-axis just has 3 tick marks. One is like black, blonde, and brown, maybe.
Okay. And then here I put weight, and I said color. Is that possible? Am I allowed to do this? So weight's a number, yeah.
With those things, wouldn't you have to like code it so like for color, maybe like if the saturation of the color gets darker, that indicates a heavier weight, and for hair color, you would have to like code it so that maybe black is on one end, blonde is on the other end.
Okay, so yes, okay. So regarding the weight and the color, we have to say, okay, how can we have color represent a number? Okay, and we say, okay, well, what's the so as far as colors that are able to represent kind of a range of values, now you're going to have to kind of have a gradient, right? You have a gradient, and maybe on one end you have white, and on the other end you have, I think default is dark blue, all right? So you're going to start at white on one end, and as it gets darker, that represents larger values. But you can imagine other kind of color gradients, right? And so you can start with, you know, yellow on one end and it becomes orange and becomes red on the other end or something like that. And we often see these color gradients. You have green on one end, and as you start entering the danger zone, it becomes yellow and then orange and then red. And this is like, you know, the temperature on, or your like battery levels, right? Or something like that. So we're accustomed to certain gradients. Okay, so here we have light blue and dark, I guess black over on the other end for weight, okay? And then, yeah, so the vertical part, yeah, we just have 3 tick marks, okay? We just said black goes here, blonde goes here, and brown goes here. Now, that's because R has no idea. R doesn't have any interpretation for these words, doesn't know that. I suppose we could take hair color and put it on a gradient, right? And we could have people with very light colored hair on one end and dark colored hair on the other end, and you have, you know, people with brown hair somewhere in the middle and stuff. That leaves out people with like red hair or people who've dyed their hairs, and, you know, where do you put people with gray hair who are naturally blonde versus naturally brown hair versus naturally black hair or something like that. So, right, there's kind of like a, I guess, for people who, I don't know, yeah, it's a little bit trickier, okay? So, but R doesn't know that, so it just sees 3 categories, okay? And, you know, and just says, okay, some people are in this category, and we're gonna just arbitrarily put this color in this position on the y-axis. We're gonna put this color, or like this category on this position on the y-axis, and this color at this position on the y-axis, okay? Yeah, so there's kind of 2 kinds of categorical variables. There are ordinal ones where there's a natural ordering. Things like t-shirt size, there's a natural ordering. Extra small, small, medium, large, extra large, double XL. And it makes sense to arrange your t-shirts in that order versus, say, alphabetical order, okay? Other things, there's not really a natural ordering, okay? Like if we say, put the 50 states in order, what order should we put them in?
Population.
By population, greatest to least. So we put California first and Wyoming at the end. Sure, that could work, okay. But then what happens 40 years from now? Your order is going to change, okay? So is that the natural ordering? It just happens to be the ordering right now, okay? Alphabetical order? I don't. Does that make any sense? I mean, like, why is the alphabet even in the order that it's in? And it's like, well, that's just how I learned it. But there's no reason why A should come before B and B should come before C. That's just like, we've accepted this and we said okay, but there's no reason for it. So there's not a natural ordering for the states. Okay, there isn't.
If you said like the total area, could that be one?
I mean,
it's hard to change.
You have to. I mean, probably the natural ordering would be the order in which they joined the United States, and then we would put, there'd be debate: North Dakota, South Dakota, which one came first, and nobody knows. Okay, and then Alaska and Hawaii comes at the end and stuff like that. That might be the quote unquote natural ordering, but who knows the natural ordering, the order of which states joined the United States, and so I would argue there's not kind of this agreed upon natural ordering that just makes sense, that have kind of intuitive things, right? So certain things like the states, or like brand names, I don't know if make sense of a natural ordering unless you're including another variable like the population or like the area size, okay? You're basically you're making an argument for the ordering to be based upon another variable, not the original variable itself, which is just the name, okay? So here, if we just say, okay, there's not a natural ordering for hair color, and maybe there is, maybe there isn't, this is just what it means to map that variable to the y position, okay? And again, this is the same information, okay? This information, the same information is here. It's a little bit harder, okay? But we can say, okay, we have two people with brown hair. One is female, one is male, and this is a little bit harder. But we could say, okay, what is the weight of this person with brown hair? And we'd say, okay, well, their color is very dark, and so something around 120. What is the weight of this person with brown hair? Again, I don't know, 140. I don't know. Okay, that's my hesitant voice. So I don't know. That's kind of the guess. And so again, when you have to go from the brightness or darkness of the thing to this, our eyes and our brains aren't as good at doing this kind of thing, and this is why where did our favorite map of the day go? Okay, and I said, okay, which who has better ACT scores, Montana or Nebraska, which by the way is right here and here, and it's like, oh, I can't tell. Okay, right? And even these three that are like all adjacent to each other, like, do they all have exactly the same ACT score? I'm not quite sure, right? So it's tough to tell. It's tough to tell, and we're just not as good at this kind of things. But it is possible, and this is just a valid mapping. I would say it's not as pleasant or easy to interpret it, but it is valid as far as mapping the data to a visual space. Now, as you gain experience, you're going to start to learn which kinds of things should I represent on the x-axis or the y-axis or things like that. Okay, so I wrote, on the surface, representing a number with a y-coordinate might seem different from representing a number with the color of a point, but at an abstract level, we're doing the same thing. We're just taking some value in the data and moving it to some visual property, okay? So I have a few more of these things, and I kind of have to go quickly. Okay, we're going to just skip over this. If you wanted to create a similar plot using base graphics, it's like a lot more work. And if you ever have to like create a legend manually in base graphics, it's a pain. And so you could do it, but we don't want to. So the key when we're doing Ggplot, and we will spend a lot of time over this, the key kind of parts of the command is, first you say, where's your data coming from? And you give it the name of your data table or data frame. My data frame is just called DF, but it could be, you have a data frame called automobiles or a data frame called states or something, okay? And then the mapping, each of these things are basically names of different columns in your data frame, names of different columns. And here we're going to say, we want to take that column height and tie it to this aesthetic attribute. And so here I have my aesthetic attributes are X, Y, color, and shape, but we can also have other aesthetic attributes like the transparency level, which uses the name alpha, and the size of the point and stuff like that. Currently, here I just said all points should have size 5. All points should have size 5. So size 5 is not, the size of the point doesn't represent anything in the data. This is just a setting and not an aesthetic attribute. If I had another data set and I wanted to use the size of the point to represent some aspect in our data, then we could do that. All right, so here I said starting from scratch, if I just do this, here I said data frame, aesthetic mapping height to X and weight to Y, it looks at the data and it creates axes for us, right? And it creates kind of these natural limits on one end and on the other end, but we don't have, I didn't add any kind of geometries. I didn't say create points or create lines or anything, so it just starts off blank. So I have to take this and I have to do something like add points, add Genome Points, and here it takes our 6 data points and it plots them, okay? And right now, there's only 2 variables being plotted, the height and the weight, and so that's all we have. We have no idea the gender or the hair color because that is not included inside our aesthetic mapping, okay? This theme line draw, I like to use as far as presentations in our class because this is actually gray with white lines, but because of our projector, which kind of just washes everything out, you can't even see any of this tick marks. So the line draw like forces these lines to be drawn where it's a little bit easier for us to see, okay? Another theme will not draw the lines as solid. It'll kind of make, solid black lines and light gray lines and stuff, but those again get washed out in the projection. So here I can say, all right, add points, and this time map gender to the color, right? And so if I do that, now we have 2 colors, female and male, and we can see this is the same kind of data. We don't have anything on the hair color, nothing on the shape. Oh, and I've run out of time. Okay, all of this to say, here I'm setting all the colors to blue, so and all the sizes to 10. So now there's only two variables being plotted here. Okay, let me give you your last view quiz answer, which is the letter E. E as in elephant. E as in elephant. I've given a couple examples on like changing the scale. We'll spend some more time on Ggplot. This is quite an important section, being able to create good quality visualizations. Okay, E as an elephant is your 3rd view quiz answer. Have a great rest of your day. We will see you on Friday.